Yeah, right. Good afternoon. So today we will see how to work with one important tool, what you call it as a Tessent, right? Um, we have a couple of DAs on this, so I want you to keenly watch. And this tool is again very simple tool. Like till now we have seen uh, like if it is a combo logic or a combo circuit, so you could write a Verilog code for that, and this need to be read by the tool. Once it get read, once this Verilog code is read by the tool, you can generate the corresponding deterministic patterns, apply the patterns, and then find out the list of fault that get detected, and finally you will get the coverage. So this is what you are expected to do. Of course, we have discussed the same thing in the no, theoretical point of view. We would like to do the same thing with this Tessent tool. The Tessent tool is a tool from Mentor Graphics, and I request you to create a login. I have already instructed Karthikeyan, so probably there would be a login created for you all. So you can go ahead and access the Tessent tool, and I want you to go line by line the comments which has been given. In fact, I want you to rework on the back end of this using a help menu. Though I will be giving certain instructions regarding each comment, but I want you to do some sort of background work, like each and every comment, what for it is being done, what is the purpose of this, what is the variant of that, right? Like that, and how the things get varied for each and every command which we are trying to give forward. So that's the whole idea. And for creating a circuit, combo logic, you can create your own Verilog code for any particular combo logics, or you can even take some of the benchmark circuit. So both has been shown for you, benchmark circuit. Both has been shown for your reference, so you can just go ahead and look into it, right? So that's the whole idea. So pick up one circuit, write a Verilog code for that, then make the tool to read it and generate the test pattern, list out all the structured faults, and generate the test patterns, apply the test pattern, find out the list of faults that are being detected. Finally, you get the fault coverage for this particular circuit. So this is with respect to combo. If it comes to sequential, what we said, replace all the flip-flops by a scan flip-flop and try to figure out the total number of fault sites. Apply the test pattern, generate test pattern, apply the test pattern, and find the fault coverage. A typical manual is also being kept. You can just go through that. It's available in the, I think, a temp folder in the Tessent tool. Right? You can go there to the temp folder and try to go through the manual. Anyway, we will also look into that manual now shortly. After doing that, then you can just go ahead and work on it. Yes. Now let's start. So basically, this two tasks which I am showing, trying to show with the tool, is one with the combo logic and another one with the with the sequential network for generating or including scan. Remember, I am just trying to show you a overview, right? But at the back end, I want you to work more on that for the DA which I am trying to give. So course, this video get recorded. You can also cross check at the later time and then go on. Right. Let's see the first one, the task, the first simple tutorial one. This is test pattern generation for a combinational circuit. So this is what we are going to do using Tessent Tool, like how to generate the test pattern for any combinational circuit that is being done. So objective to generate the test pattern for any combinational circuit. As I said, the combinational circuit could be from a benchmark circuit, or you can write a Verilog code, or if some circuit is being given, you need to write a code for that and then try to feed that as an input. Right. One important thing, this Tessent tool, T-E-S-S-E-N-T, this is the Tessent. Tessent tool will accept Verilog code only in gate level. Don't try with things like behavior level, or you don't try with the switch level. It is workable only with the gate level modeling. So try to write your code in the gate level modeling. That's the only constraint which you need to follow. Right. The next thing. Now, I will show you a folder while working with the tool. After entering into that folder, you can do the whole process which I am going to save subsequently, which is around 8 to 9 step, right? Yeah, 8 step. This 8 step can be finished using a single do file, right? You can do that using a single do file. But I wish you need to do step by step. It's like writing a script. I believe you are working with BASIC. There you can completely write the script and invoke them once in order to execute all the commands. Similarly, you can also do here in the Tessent tool. So you can write a do file and now invoke that once in a single command. You can get everything. All right. So what is there in it? Let's try to look into it. So this command, Tessent space hyphen shell. This is the command used for invoking Tessent tool. Right. So after this portion, Tessent space hyphen shell, then space do file. It's a syntax. The do file which we have kept is atpg.do. atpg.do is the do file which we are trying to activate now or use it. So ATPG, automatic test pattern generation. Right? So this do file is invoked, and we are storing that in a log. Log means a list of events which you are doing will get recorded. This is basically used for tracking, back recording to find out where the things went wrong. So always this log file will help you. Right. So what are we trying to do? Look at here. This minus log file is again a syntax. Log is a file name which you can use it. You can use log underscore Shakti or something like that in order to store the log events in that file, and you replace means if there exists, you keep on repeating it, you can keep on overwriting on that. So certain things are syntax. So basically these are the syntax, like Tessent space hyphen shell, then hyphen do file, hyphen log file, hyphen replace. All these are an appendix for the single command which you are trying to do. So a do file is invoked and a log file is being generated in order to execute a set of instructions. That's all. So as such, if you say, if you invoke this single command, it will give you the whole history. I mean, the whole list of commands which we are trying to do now. Or indirectly, this ATPG consists of all the subsequent 8 steps which we are going to look in now, that is being stored here, where you can use it one by one. So for a better understanding, you can go step by step. Right. So let's start with the first one. The first is set context for test pattern generation. Context here refers to, like, the tool can be put up in 3 modes. That is setup mode, insertion mode, analysis mode. So when you run the tool, you can put them in three modes like setup, insertion, and analysis. So first thing is set context for test pattern generation, which will decide the operation of the test tool. So what are you doing is the first command is set underscore context pattern hyphen scan. So what are you trying to do is put that in a scan mode or set up the environment for a scan mode. Right? So make sure this particular command get executed. Set underscore context pattern. This is for pattern generation, automatic test pattern generation, hyphen scan. The second step is again these are syntax. Set underscore context is a syntax. Read underscore Verilog is again a syntax. Now the file which we are asking it the tool to read is c1.v. So c1 is my top of file or top module, right? .v is a Verilog file. So you can give a gate level .v file as an input. As I said, it could be even a benchmark circuit whose code is written in Verilog, and you can also come up with your own circuit. Here simply c1.v is my Verilog circuit. So now you have set an environment, set context pattern hyphen scan. Second step, you have made the reading of this file c1.v. Step number top module name as the typically same as what you do in synthesis, right? In ASIC synthesis. Set the top module as the current design name. So what you try to do, whatever name you are given, the top module name should be the current module. Set current module design name C1. Here C1 is the top module, so we are trying to use C1 as the current top module, right? Next, set the mode of operation. As I said, there are three mode of operation. The three different modes are available in Tessent, namely your setup, insertion, and analysis. In the setup mode, the requested Verilog files and the libraries are attached. So what they are trying to do is, in the first setup mode, you try to use all your Verilog files, and in case if you have any library file, that could also be included over here. The scan insertion mode is done to insert the scan flip-flop or inserting scan. So that is the second step. The third step is the pattern generation and the fault analysis is performed during the analysis. So basically it has three modes. First, reading all the Verilog files and feeding in case if you have any library file that will be given in setup mode. Second is insertion mode, that's scan insertion mode. Third is analysis mode, that is pattern generation and the fault simulation and finding out the fault coverage. That comes under the analysis mode. So that's what we are trying to do here. Set underscore mode, you need to make sure it is in the analysis mode, which means your file has been already read. Now you have put that in scan. Now what are you trying to do is trying to generate the test pattern and apply the test pattern and finding out what is the list of fault that's nothing but a fault simulation method. Right. Second step, once you put that in analysis, this is the command. Select the fault type, stucket faults. Basically, all the fault which we are applying is the fault stucket fault. Again, this is the default to fault model. Stucket fault models is being applied. So to do that, add fault hyphen all. So this command add faults. This will add all the faults available for that gate. Basically, here by default it will add the stucket faults. Next one, generate the test pattern for the fault model. So here the fault model, as I said, it is stucket fault, and for this stucket fault you are creating a test patterns, creating test patterns. Then generate the report which contain fault coverage. So now we are asking to generate a report for the fault coverage and the list of fault selected. Now for this you have a specific command called as report underscore fault hyphen class ds, detectable fault. This ds is detectable fault through simulation. That's what the shortcut for ds. because you have some of the faults undetected faults. So that has UD, I believe. There is one more option called as UD, undetected fault. This DS is detectable fault through simulation. So what are we asking to do is report all the fault hyphen class DS indicate all the detectable fault through simulation. You list out all the fault. Once you list out all the fault, then what are we asking to do? Your report has been generated. Write the test pattern in both ASCII as well as in the Verilog format. So you can ask to write the test patterns which has been generated for your circuit which you have given. Um, so in ASCII format you may not be able to read it, so possibly you can ask to write in terms of Verilog format for readability of the fault simulation. So the command for that is same. You use write underscore pattern dot slash c1 underscore means we are asking to write it on a pattern. Look at here, c1 underscore pattern dot ASCII hyphen ASCII parallel. Parallel is the parallel mode of simulation. Again replace. So this is the file name which get stored. This dot indicate, I believe you know all this basic thing. Dot is the present working directory. You are asking that to store in the c1 underscore pattern ASCII format. So two format you are asking to do. Again the same write patterns dot slash c1 pattern dot v. So this is the Verilog format of the list of test pattern generated, and this is ASCII format, this is Verilog format, and the parallel type of simulation is being done, and whenever you run multiple times this get replaced in the same file. That's it. So this is the first no? So this is the first objective of this particular task using Tessent. Now straight away let me go with the tool simulation. Yes, I am using MOBA extern, you can also use that the same, and I believe people, I mean for your login would have been created with the mental graphics, so please go on with the same. I am going with my own login, so RST at the mental graphics, right? Let me list of files here. I have kept all these files like basic underscore ATPG, demo underscore Tessent, and I have used one more Tessent underscore workshop. So in this folder, this blue color will always be a folder. All right, I think in the in the Linux you know that. So this blue color is my folder. Let me enter into that folder. So I am just using CD to enter into that. So again, I am long listing everything. Let me find out what are the things available in it. Again, what I could see here is DFT underscore SEQ, DFT underscore combo, basic underscore ATPG. So these are the things. Of course, you can read this readme. So how do you read this? You can use more command, more read, or you can even so these are the comments in the DFT underscore combo contain files for combinational circuit, DFT underscore sequential contain files for sequential. Here the file which we are using for sequential is S2 298.b. This is the benchmark circuit. For combo logic we are using C1.b, right? Basic underscore ATPG contain files for the complex sequential circuit like CPU.b. Maybe you can go there. Now I am interested to go with the DFT underscore combo. Let me just go with that, like CD DFT underscore. So this is combo. Let me list out and see what are available in this. Yes. So what is being done here is, see, can you notice this file C1 underscore ATPG.do. Do file is there. One do file is there, and ATPG underscore log file is there. C1 underscore fault underscore sim.do file is there, and c1 pat f1 ASCII file is there. c1.v, this is the Verilog file which we are going to work with. In fact, you can work with anything. There is a circuit PDF, demo log, dft underscore log, fault sim.do file. Like this, you have all this file. Let me check with this. Actually, we are supposed to atpg.do file. Okay. I think atpg.do file is there. C1 atpg.do. Yes. Let me check whether that works well. Okay. Right. Now maybe we can read what is being said here. So what are the things being given here? Use the following command for scan insertion. In case now we are not doing the scan insertion. This is tessent shell.do file c1dft.do -log. So this is the command. Like of course we have used what we have used atpg.do, but the file which is available here is c1 underscore atpg.do. Of course, can you see here? c1 underscore atpg.do. That's the file available. So in fact, we need to use this command for scan insertion. -log file dft underscore log. This is the log file which get generated. Already I think, yeah, you have a log file here. Hyphen replace test pattern generation test center do file c1 atpg.do. The same. This is for test pattern generation. Sorry. atpg.do c1 atpg.do file is there. c1 dft.do file is also there. Where is c1? c1 dft c1 dft is there. Do file. One do file is this one c1 atpg. Oh, it has only that. So c1 dft will be available. So this doesn't have any scan. So basically it doesn't require any scan file for it. Okay. Now let's see. The next one is Tessent. I mean, to open, yeah, to open the PDF, I think you know this command. Acro read is the command for opening any PDF. To open tool manuals, yes, this is where the tool manual is there. Maybe you can go there, home/mgc Tessent document, or I think last time we asked them to keep in tmp temp file, so you can also go through that also. atpg._gd.pdf for scan and atpg manual. You can just go here, open this this PDF, and you can also read this. Then tshell underscore reference for the essential tool manual. So these are the manuals which are available. You can go to that location. I believe it is also available with the temp, or else you can go to this location and see what are the PDF documents that are available. Right. So now let's look into this command. Tessent yes, simple. I have used a single command format. But for the want of time, I have used it as a single command. But what I want you to do is you can go step by step. Now let's see here. Yes. Yeah. Um, this is the command which I have given. Tessent shell 2 file C1. So what is happening here? Now let us see step by step what are the things that get invoked. So this is the command given by me. Then Tessent shell. So it is opening the tool Tessent shell. So again, this tool is from the metagraphics. So let's see what are the commands which is getting executed. First command, set underscore context pattern scan. Typically what we have seen here, right? So this command, it is getting executed. As I said, you can first give this alone, tessent hyphen shell. Following that, you can give all the commands. You need not go with the do file. So the do file will put you all the commands in a single thing, whereas you just go with one by one with all commands which has been listed out. That is what happened. Any doubt? Hello, any doubt? I think there is Sukanya.
Sorry, sir, by mistake it got unmute.
It's okay. Right. So these are the comments like set. First, you are making it the scan, read the file c1.v, and before that, we didn't see what is there in c1.v. Let's see what is that. Then set current file as c1, set analysis mode as analysis. Then your again the tool will do the flattening process. It has listed out after reading. It has listed out total number of gates 11, primary inputs 5, primary outputs 1. CPU time taken is almost 0. Begin circuit learning analysis. What is the? It started its analysis. Learning completed. Begin scan chain identification process. Actually, this is a combo logic, so you will not be having any memory. So that becomes 0. Circuit has no memory element. Now it is going to execute another set of commands, that is add fault hyphen all. So add fault is the command. So it is listing out it is adding up all the stuck faults, create patterns. Now this again start generating the pattern for the stuck faults. Now let's see what is it happening. Analyzing the design, current clock restriction networks domain. So if there is any restriction on the clock, it is just looking for. Now current split capture setting, no, since there is no flip flop, all this becomes invalid. Current abort time setting 30 and 30 unit of time, set abort setting 300, all these things are sequential depth, it is 0. Now we are trying to understand what is happening in this simulation performed for number of gate is 11. The fault that has been identified, stuck fault, is 40. System mode is analysis, pattern source is internal pattern generation. So now it has listed out in a table total number of patterns simulated, deterministic pattern 7, test coverage ATPG 100%. So it has covered all the fault, 40 fault. List of fault in the list invoked with number of fault in list invoked with 0. Number of fault detected with the combo sequential, it is 40. That's what we have said. Total number of fault is 40. It has detected all the 40. Number of effective pattern aborted limit time 7. Test pattern limit is 300 by 100. This is with respect to timing, I believe. So it has listed out 40 faults, and all the 40 faults has been detected using the deterministic test pattern generation. So thereby what we understand is, so it has 100% fault coverage. let's see what are the fault classes. Like we have seen earlier, no? DS, class DS. So this DS indicate it is the deterministic simulation or fault that can be detected using simulation. So uh, that is 40. So total fault detected is 40, and they are all detected via simulation. So fault coverage is 100%, and the ATPG effectiveness means how effective the test pattern generation is 100. Number of test pattern that has been generated is 7. Simulated pattern, they have used all the test patterns, 7 test pattern. Time taken for this is 1.8 second. Then coming down to the list of faults, command report fault. We have said the report fault slash hyphen class DS. No, the list of deterministic fault through simulation. That list has been given. Look at here. So from the C1 circuit Verilog code, you could understand what are the type of faults. Stuck at 0, stuck at 1. These are the list of type, and this is the type of fault, whether it is detectable fault or EQ represent one more type of. I think we need to cross check what does that EQ represent. Like this indicate the code that has been used for representing that fault and where it is available. Means which portion it is in the output of an AND gate or input of an AND gate, which terminal it is available. So it has given the pin path. So here it has listed out all the 40 path fault that are available. That's it. And finally the last command, write pattern dot pat. Actually this do file has written not like here we asked to write it in this name. In fact, this name you can keep it according to your own will and wish, but in the present do file it has been written something like this. Look at here, pat underscore struct underscore bar underscore c1 dot ASCII file. So it has written only uh, ASCII file. Let's see, is there any. You can also write that as .b file. Got it? So that's it. The whole command has given out. Now we can also write this. We will make this as score uh, this very long. So make this is very long. Yeah, that's the syntax which we need to follow. Not B is fine, I believe. Okay, very long parallel replace. Right? Uh, not space hyphen Varilla parallel right. Okay, now let's see what we expect is it is supposed to write the pattern in the name Shakti underscore C1. Let's see. Yeah, so it should be having there. Now let's exit from here. Let me list out a long list and see whether Shakti C1.v is here. Yes. Before that, let's try to see what is there in C1. So I am just using a command or gedit, whatever you want, you can use it. C1.v. So yeah, this is a very simple code you could see here. Module C1, simple NOT gate, AND gate, all this, one AND gate, one NOR gate is there. So for this, the complete combo logic, we have written that. Let's see what are the patterns. So what we can do is .v. Yes. So this is what these are the things which has been written in. So fault is occurred and timestamping is being given, coverage 100%. So it has given a complete list. Begin verify section. What is the file format, file name? So it has given what are the integers, things like that. 3% here, but reading it. So it's a long read. So it's like the 7 test vectors, one by one. Right? 3, 6, or even more unknown that has been generated. The complete list is there. Maybe you can just go through this one, what's being written in that file. Out, it's a lengthy file. Okay, so if you want to know what is there in that do file, let's open that also. G C1 underscore but whether it will get open. This failed to open this do file. Maybe it can be the do file format is not being supported here. Now I open like this C1 underscore ATPG.do. Right only. Yeah, I think it is not supporting this opening. So what would be there in the ATPG is .do file. It has all the list of comments which has been written. Maybe you can even open that. G will G1 C1 pg.do. Okay. It says something like this. Unregistered. Yeah, it's here. Can you see here? So these are the list of comments. The comments which I have listed there has been portrayed over here. These are the list of comments which is used for running the test pattern generation, and these are for the reading. The same thing. Got it? So now we know. Yes. Now we know how to read a .verilog file, and then how to apply a test pattern, how to write the test patterns, in a Verilog file how to analyze that particular circuit. Now the same thing, second portion of it, let me try to give that. All the other things are more of self-explanatory. Now let me go with this second portion of the same. This is for fault simulation. This is activating the fault at any particular node. Say suppose if I want to have a fault at a particular node, we have seen in the theory like you can include one AND gate or an OR gate to insert a fault over there. So this job tries to activate a fault um, in a particular circuit C1. So for circuit 1 or 0, you can insert OR gate or AND gate in the RTL code and perform the fault simulation. This is like externally inserting a fault. The previous case was to find out the stuck fault, you give it a null and then do the pattern generation. This is I purposely inject a fault and then go for a fault simulation. That's all. Let's see. Same procedure, Tessent and a do file. Here the do file is fault underscore sim dot do. First of all, you need to check whether this do file is there in that particular folder. So that you need to make sure. And as I have opened right now using gvim, you can also open that and see what is there in that. Then log file log underscore fault replace. All the other things are same. This command remains the same. Read verilog c1 dot remains the same. Set current design, you need to make it same. One here you need to make sure that you need to put it in analysis mode. So to in case if it is not going to analysis mode, you need to make sure that it enters into the analysis mode. Then you apply add underscore fault hyphen all, create pattern, then report the fault DS, statistics of the report, then write all the uh, test patterns so that you can write it in the uh, file like c1 underscore pattern dot. So you can do like this. Let's see whether this file is there in that particular folder, that is fault underscore sim dot do. Now let me uh, fault underscore sim dot do. C1 fault underscore sim dot do. Did you notice that? So it is there. Typically you need to give the same command, and which will make you to get the result. Let's try to see whether can I get Tessent L hyphen do file. The do file is, what is the name of that? Sorry, do file is fault underscore sim c1. It's not fault, c1 underscore fault underscore c1 underscore uh, hyphen log file space. Actually you can give the log file some other name. So log underscore fault, let's give yeah, now replace. That's it. Let's see, this should open. So what I'm trying to do is Tessent space eventually I have opened the tool and I'm trying to invoke this do file. I I understand that the do file is there, c1 underscore fault. In fact, you can open this using gvim and see what is there in that. Minus log file. Again, log underscore fault is my log file. And now let's try to see. Yes. So it has given the same type of thing you could see here. Simulated pattern 1. So it is a deterministic test pattern which has been generated. These are the list of faults that come across for that fault which has happened. Here what is being said, uncontrollable fault. Can you see here? UC indicate uncontrollable fault. Uncontrolled fault. UO represent unobserved fault. DS represent fault detected using simulation. So the fault coverage is only 25% for the fault which has been incorporated or injected. Right? Test patterns simulated is 1, but the fault total fault is O. Since we have given, right, the thing is, since we have given one fault, and we have injected one fault, and in the command we have asked to calculate for all the fault. See, fault, add fault hyphen all. So this will include all fault. So the list of fault remains the same. Number of gate, everything remains the same. Only thing is, for the injected fault, it is generating the test deterministic test pattern. That's where the difference comes. So here it comes to somewhere the fault coverage comes to around 25% only. That's it. So this is for combo. Like this, you can take up any one circuit, and I wish you should go with the possible. You can also give external test pattern. Now this is externally you have forced one, what is that, injected one fault. The third option is you can even go ahead and do or add up external test pattern. How to do that? So here up to repeat the step up to 4 for fault injection. You have already seen the steps for fault injection. Then generate the test pattern separately using ATPG algorithm or a BIST algorithm. Okay, that's fine. Right. This external test pattern can be included in ASCII file without affecting the ASCII file format. Now what you need to do is set pattern underscore source external, this file c1 underscore external dot ASCII. I wish you need to check. I think it will be there. So if you give this command, it will include the external test pattern which has been already generated. Then read, or else you can also use read underscore pattern c1 underscore external dot ASCII. Then simulate pattern, store pattern, report, and it will. You need to repeat all the commands, or else in the do file you go and add up these set of commands. That is, after the fourth step, this read pattern is there. No, you have to read c1 underscore external ASCII, and then what you are trying to do is simulate the pattern, store the pattern, report the statistics of it. That's all. So this would also work. Let me see whether that file is there. The c1 underscore external ASCII file. So here c1 underscore, yeah, here it is there. c1 underscore pat f1 dot ASCII file is there. So I think this one or c1 pat, we need to open this and check it out. Pat stuck parallel c1. I think it should be this one, this ASCII file, which is the external fault, or else I think that is the file. We need to open that and then check it out and see whether that pattern has been given there. Then you include this to be the part of the code. I mean, change the title there instead of what is being set here. Here it is being set as c1 underscore external ASCII. You change that to the corresponding file format name and then include. So that way also you can include an external test pattern to store it and then do it, right? And then apply the test pattern for that circuit C1 and see what are the patterns that has been generated and store that. So this is for combo logic. So these are the three possible mechanisms. In fact, you can use Tessent Tool for finding doing different task. So I have shown you with respect to combo. Now sequential, we have one more. Let me show the demo on the next class with sequential. Meanwhile, I will upload the DA in your login GitHub. So please start working on that. Stick on to the deadline. Maybe the deadline, can I fix what should be the deadline? Today is one. Can we keep somewhere around 10th or even before that? Can someone respond?
10th should be
10 is
fine, sir.
fine.
10th is fine.
Okay. Okay, so I will make sure it is 10th and if you take one unique circuit or the circuit which has been given to you.
Excuse me, sir.
Yes.
Excuse me. Sir, what type of a script is there in .da script? Which type of a script is there?
No, .do you are asking?
Yeah, .do.
.do. It's actually it is an extension. Like I have opened in GVim. No, you need to save that as do.
Means
Or take that.
.tcl means TCL script. Same as .do means what? Which type of a script is it?
I am not sure about that. What type of script is that?
Okay, sir.
But on the other end, you can take that do file and start editing that also. That will also you can do in case if you have. But I don't know what type of scripting. I am not good at scripting.
Okay, sir.
Yeah, please answer your attendance. Roll number 1. Start from 1.
One present, sir.
2 present, sir.
3 present, sir.
4.
5 present, sir.
6 present.
7 present, sir.
8 present, sir.
9 present, sir.
10 present, sir.
11 present, sir.
12 present, sir.
13 present, sir.
14 present, sir.
15.
16 present, sir.
17 present, sir.
15 present, sir. 18 present, sir. 18 present, sir.
19.
90%, sir.
20 present, sir.
21 present, sir.
22 present, sir.
23 present, sir.
24 present, sir.
25 present, sir.
26 present, sir.
27.
27 present, sir.
28 present, sir.
29 present, sir.
30.
31 present, sir. 32 present, sir.
33 present, sir.
34 present, sir.
35.
36 present, sir.
37 present, sir.
38.
39 present, sir.
40 present, sir.
41%, sir.
42 present, sir.
43.
44 present, sir. 45 present, sir.
46 present, sir.
47 present, sir.
48 present, sir.
49 present, sir.
50 present, sir.
53 present, sir.
54 present, sir.
55 present, sir.
56%, sir.
57.
57 present, sir.
58 present, sir.
59, yes, sir.
60, yes, sir.
61 present, sir.
62 present, sir.
63 present, sir.
64 present, sir.
65 present, sir.
66.
67%, sir.
Yes. Anybody else absent?
Sir, 4 present.
44 present, sir.
This 51 is absent, right?
Sir,
Yeah.
44.
44 present only.
44.
Sir, 35 present, sir.
So someone saying, what is that? 44?
Sir, 35 present, sir.
Sir, 4 present.
Why always 4 you switch on and you go out?
Sir, 44, sir. Present.
Array 44 is present only, man. Are you sleeping? Class has been over. Venkat, no. Venkat?
No, no, sir. Mira Hussain, sir.
44 is your number. If it is 44 is
No, sir.
yours,
43. 43, sir. 43 is mine. Yeah.
then why are you saying 44, 44?
No, sir. 40. No, sir. 40. Yes.
So now everything okay?
Okay, sir.
I think you are in deep sleep. Okay, anybody else? Yes, okay. So I will upload the DA1. Please complete it within the deadline. Okay? Okay, fine. Let's meet.